we're going to look at graphing sine and cosine functions given an equation. So to start us off, let's look at a cosine graph. We've got y equals 2 cos x over 2 plus 3. Our first step should always be rearrange the equation if there's anything you need to factor out, especially around the x. If you need to factor out that b value, you want to do that first. This graph is a little nice in that it doesn't have anything for a horizontal translation. But let's just rewrite it slightly to make it a little more clear what our b value is. So we have y equals 2 cosine. I'm going to factor out that 1/2 and just write it as 1/2 x rather than x over 2 plus 3, just to make it really clear what our b value is. And then we're going to look at what other information we can get out of this graph. So our a value is going to give us our amplitude of the graph. In this case, our amplitude is 2. This is also where we're going to get, if we have any kind of reflection, there'll be a negative sign there. For finding our period, we're going to use that b value, and we're going to calculate 2 pi divided by the absolute value of b. In our case, that's 2 pi divided by 1/2, so our period is equal to 4 pi. We know the graph is expanded horizontally by a factor of 2, so that kind of makes sense. We don't have a phase shift for this one, so that's kind of nice. We won't have to slide it left or right. We do have a vertical displacement, so it looks like the graph is going up 3. So we call that our midline because the graph is normally centered at a y value of 0. Now it's going to be centered at a y value of 3 instead. So we can think of it as sliding the graph up 3, or we can think of it as a midline of y equals 3. Let's take a quick peek at what a regular cosine function looks like without any of these transformations. So I'm just going to put a scale on. That's nice and convenient for us. There we go. A regular cosine graph without any transformations starts at a value of positive 1. It has a period of 2 pi, which means after we go for the full period, we're going to end up at our maximum again. Halfway, we're going to be at pi. That's going to be our minimum value, which is going to be negative 1. Okay, and halfway between the maximum and the minimum, we're going to be crossing our x-axis. Again, halfway between the minimum and the maximum, we're crossing our x-axis. So we have a nice kind of like curved shape. I'm going to try my best to try and curve it as I draw it. But that's kind of the basic idea behind one period of cosine, and then it repeats. So if I want to do multiple periods, all I have to do is kind of mirror the points and go along. So if I want to add another point to the right, I'm just going to go 2 more, or another point to the left, I'm just going to count another 2. And it kind of keeps going. So we want to follow that same kind of easy step for drawing, except we're going to be changing our scale a little bit, and we're going to be shifting where the graph is. I'm going to pause and just take away this graph so we can put on our fresh graph. Okay, and a new convenient grid. So we know we're going to be centered at a y value of 3. We're going to be going up 2 from that, so I'm making sure that my grid goes past 5. Similarly, I have a period of 4 pi, so I might as well stretch out the graph, and maybe I'll make this fourth line 4 pi, and the other ones can just be 3 pi, 2 pi, and pi, just so it's kind of nicely spaced out and it's easy to fit all my points in. The other thing I can do is sketch in my midline at a y value of 3. Again, it's not an asymptote, but we usually do use a dashed or dotted line just to kind of indicate it's not the graph itself, but it's something that we use to draw the graph. Once I've done that, I want to pick a starting point to kind of figure out where should I be starting. Cosine normally starts at a y value of 1. Instead, I have an amplitude of 2, and I need to go 2 up from the midline instead of 2 up from 0. So I'm actually going to have a starting value of 5. So instead of starting at 1, I multiply by 2 to have a starting value of 2, and then because we're going upwards, we end up at 5. Or count from the midline up 2, and there we go. The other thing I know is that I have a period of 4 pi, so after 4 pi, I should end up back at that maximum y value of 5. So I'm going to put that in right now just to make life a little bit easier for myself. So I know that maximum value of 5 for y. I actually also know my minimum value for y. So because we have a midline of 3 and an amplitude of 2, my lowest y value is going to be 1. And the nice thing about cosine is exactly halfway between the two maxima is where our minimum point is going to be. So at 2 pi, which is halfway between 0 and 4 pi, I'm going to have a y value of 1, and that gives me my minimum. Halfway between 0 and 2 pi, which is at pi, that's where I'm crossing my midline. And again, halfway between 2 pi and 4 pi, at 3 pi, I'm crossing my midline again. So I've taken into account my vertical displacement through the midline. I don't have a horizontal displacement or a phase shift to worry about. I've taken into account my amplitude. There's no reflection. And I've taken into account the period. So everything is taken care of. All I need to do is kind of sketch in my nice curved line. If you need more than one period, all you have to do is keep adding points. So if you go another pi, you're going to cross the midline. If you go another pi, you're going to be down at the minimum again. If you need to go to the left, go pi left. You're going to be crossing the midline. Another pi left, you'll be at your minimum. Another pi left, you'll be crossing the midline. Another pi left, we're a little off the grid, but you'll be at your maximum. So it's actually, once you have the basic shape, it's really easy to just repeat it to extend your graph if you need to. And that's kind of our basic idea.